be solving another LeetCode problem, LeetCode problem 2369, and you can pause this video and go through the question first and then come back. I hope that you have tried this question and have gone through this question. So we can now start this question. So question is very simple. It's not too complicated. So question says that we need to make valid partitions of the array, and if we are able to make any valid partition, then we can return true, otherwise we have to return false. So what is a valid partition for the provided question? We'll start with that. So one valid partition, the question says, is that we can partition a subarray such that it has only two elements and that two should be equal, like 2 comma 2. Okay, same in the same way we can have exactly three elements, all three should be equal, like 4 4 4. Okay, and one more way, the question says that we have to we should have three consecutive increasing elements, that is 3 4 5, 1 2 3, 7 8 9, like this. And if we are able to do this, at least one partition, we can say that okay, the array is good array. Okay, let's check some test cases and then we can check further. Okay, so I'll take this one. Okay, okay, so let's check with the first part, the first way. So first way say, can we do two equal numbers for this? So for two equal numbers, at least we should have two numbers, so we have to do here itself, right? These two. Okay, we have these two. So 4 and 4. Okay, but rest part we should check. Rest we need to check. Okay, now if I ask you, can we do it from the second method, that is 3 three numbers should be same. So 4 4 and 4, these three. Okay, this also is fine, so rest we need to check. Okay, now the question says, can we the subarray can should be exactly three consecutive increasing elements. So are these three increasing? No, they are not increasing. So 4 4 4, this itself is wrong, so let's not consider this part. Okay, now what is the rest that we need to check? For this one we need to check 4 5 6. So 4 5 and 6, again we can apply that 4 5 6, right? I'll write it here. Okay, so can 4 5 6, can I partition this in with the first way? So 4 and 5, are these two equal? No, this is not equal. So from, if we are going with 4 and 5, so we can't go, okay. Let's check, can we go with the second way, 4 4 4? Is it equal? No, we have 4 5 6, so 4 5 and 6 also we can't go. Okay, now I say 4 5 6, now can we go? We have difference, 5 minus 4 is 1, 6 minus 5 is 1, so 4 5 6 we can go. Okay, now our pointer is pointing at the end of at the end of the array. So if we are able to go to the end of the sub array, that means we have already completed the array, so we can return true, right? So this way we can return true. So 4 4 and 4 5 6, which is correct as well. if you partition 4 4 and 4 5 6 separately, we will get the answer. Okay, and if we are able to get one answer, it's fine. We can say that okay, it is working. Okay, let's check the rest part for triple four. Okay, so for triple four we have 5 6. Is 5 6 5 and 6 equal? No. Do we have three elements to check even further? No. So this will return false. But since we already got an answer, so no worries. Okay. So I think many of you will have directly got the answer. So we can directly jump to the solution. Yes. Code I have already submitted. I'll be just discussing the code. Okay. So, so, yes. So we have to start with an index. Okay. Forget the DP part. Uh, we'll just focus on the recursion first. Okay. We'll start with our index 0. Okay. Now, just we just need to be very careful of the indexing in this question. So what is let's keep our answer variable as false for now. Okay, now I ask you, what happens if uh, first way we are exploring, right? So nums of index is equal to nums of index plus 1. If this is equal, what we can say, that we have found our answer for the given part, but we need to find the answer for the rest of the part. So what I'm doing, and function of index plus 2, because 0 and 1 we are done with, right? Now we are concerned over the index plus 2 part. So and of index plus 2. Okay, either this, from this method we can get our answer. Okay, or we can have an answer from our second way. What our second way says, that all three should be equal. Okay, all three should be equal. So indexes should be equal to index plus 1, and index plus 1 should be equal to index plus 2. If this is true, then okay, this part is true. Now find me the answer of the remaining part. Okay. Okay, now as I ask you the third way. I ask the third way. What is the third way? Third way says that index plus 1 minus index, nums of index should be 1, and nums of index plus 2 minus nums of index plus 1 should also be 1. If this is correct, if this is happening, then we can say okay, this part is true, you need to find the rest of the part. Okay, now, and now since we know that we just need one true case, so I'm doing or. Okay, now, let's discuss the base case. Let's say I have completely bypassed the nums part. So I'll be standing after my last index. If I'm standing after my last index, I know that I have already completed everything, so I can return true directly. Correct? Okay, now that we should be very careful about is that we are using index plus 1, index plus 2, index plus 2, and many places 1 and 2. So we should be very careful that index plus 1 should be in our range, should be the inside nums dot size. So we should be having these checks as well. Nums dot size, it should be less than nums dot size. And in the case of second way and third way, we can use index plus 2 directly, because index plus 1 will already be covering in this condition itself. Okay, so let's discuss about the time complexity. So here we can see we have three choices, right? So we'll have an exponential time complexity. Okay, now let's try to reduce the time complexity. Okay, let's try to reduce the time complexity. Here you can see we are only changing indexes, index plus 1, index plus 2, index plus index plus 2, index plus 3, index plus 3. So if we are only changing index, we just need one parameter in our dp vector, and that parameter is nothing but our index. So I've directly created a vector int dp which will be of nums dot size plus 1, initialized with minus 1, and if we are already encountered the value, we'll be directly returning. Otherwise we'll be storing in a dp of ind. Okay, so here we will still be using a recursion stack space, because it will still be calling a recursion. So we can still optimize this stack space using by using a normal approach. We'll be directly filling our dp vector. Now we can check this. If you can see, these both codes are very similar. I'm just before this we were filling from 0 to n 0 to n. Now we are coming from n to 0, and at the last I am returning dp of 0. Okay, so directly what I am doing, int index is n minus 1, index should be greater than equal to 0, and index minus minus. Similar way what I am doing is that if index plus 1 is less than nums dot size and nums of index is equal to nums of index plus 1, I am saving first as true and dp this time. Rather than calling the function, I am calling our pre-computed answer dp of index plus 2. Similarly I am calling for second way, similarly I am calling for third way. The only advantage here is that this will be filled in order of n time, and we will be saving of recursion stack space. Okay, so time complexity for this solution is order of n, and space complexity is also order of n. Thank you guys, see you in the next video.